Welcome everyone to a short mini video series where we'll be talking about how to improve your model explainability with feature importance. My name is Daniel. I'm the current Senior Product Marketing Manager here at Truera. Joined with me today is Josh Reini, who is our Developer Relations Data Scientist. When it comes to AI models, it is often referred to as a giant black box. And because of that, stakeholders have little to no transparency when it comes to understanding the makeup of each models. On top of that, it takes data scientists a lot of time to configure open source tools to analyze their models. Truera provides differentiated explainability through feature importance. We provide out-of-the-box comprehensive tooling when it comes to understanding features across models, segments, and projects. We also provide the flexibility that users need to look at features via SDK, our UI, and if preferred, a built-in automated pipeline. Lastly, it provides the time savings that users need when it comes to focusing more of their time on analyzing the models instead of spending so much time on configuring each open source tools. There are 5 different types of feature importance. 2 of the most commonly used ones are global and local. Global looks at all predictions and how features are associated to them. Local looks at a specific prediction and how features works around it. And then you can also look at features by segments, group each features by categories, and then lastly, you can also compare features and how it associates from model to models. Now I'll hand it over to Josh so he can give you a brief demo of feature importance.
Thanks, Daniel. Here, I've trained a classification model on U.S. Census data to predict whether an individual is employed. Similar models are used every day for processing loan applications, evaluating creditworthiness, and more. Prominently displayed onto the page, you can see a panel of the top 5 most important features, indicating that these are the core drivers of your model predictions. On this page, we can also look into outliers or features with a high influence of a single point, along with features whose variance is best described by the trend or the best fit line. Before looking further, we can quickly show into the feature groups page, where you can see the model features are grouped into demographic features, those related to work or occupation, and others. This gives you a quick sense that the model is learning the most from demographic data. We can then go into the all features to learn more about the specific features used by this model. Shown on the left side of the tab, you can see a list of the features fed into the model sorted by their global importance. For this model and data split, age is the most important feature, followed by capital gain. By clicking on a given feature, you can then view the influence sensitivity plot, or ISP, of the feature. Orienting on this chart, you can see the feature values for the x-axis and model influence on the y. Understanding the ISP is useful for stakeholders and data scientists alike to understand the general role each feature plays in the model's decision making. The ISP is additionally useful for the data scientist or machine learning engineer to understand if the feature is being used by the model in the way that it was intended. This is known as conceptual soundness. Irregular or unexpected feature influences shown in the ISP can indicate issues with data or model pipelines, feature drift, and more. At the top of the ISP, we can also see the observational density. This gives us a sense of where the model may be weak due to thinner data, which is often a cause of unsoundness. Looking more closely at the age feature, we can see that the feature influence tends to increase until about age 50, and then it decreases. This is a good example where I might desire this feature to act more monotonically, indicating that I should take a closer look. From here, I can also visually compare how this model compares to the previous version of the model, V3, From here, I can visually compare how this model, version 4, compares to the previous version, version 3. In the ISP, I can see how feature influences shifted between model versions. We can also repeat the analysis we've done so far focused on a particular segment of the population. Near the top, we can just use the segment drop-down feature and then select the segment, in this case females, to filter down onto that group. After filtering, you might have noticed that the capital gain moved down in importance, where race moved up to the third spot. Each dot in the ISP represents an individual person along with their feature value for that specific feature, and the impact the feature has on their model prediction. By clicking on an individual point, we can examine how the model arrives at its decision for a given observation. This is the deepest dive we can do into model explainability, all the way down to a given point. Now on the points page, we can view all of the features that influence the prediction of the point we're focused on. Using feature group influences, we can see that demographics and work influence the prediction in the positive direction, whereas the other features causally decrease the model prediction for this observation. We can also dive into the individual features using the feature influences panel here below, where we see the education and occupation were the most influential features for this observation. A key property of Shapley values used here for feature influences is their sum, along with the offset, add to the final model prediction. This property enables highly targeted case analysis, where you can find out exactly how the model made a decision for any given person, what feature values changes could have moved the prediction, and how the model went wrong or right.
As you can see, feature importance improves your model explainability by providing time savings for data scientists, as well as the transparency that stakeholders need. For more information, please register for our free trial now. Thank you.